today we are going to talk about testing with Marc Philipp, who is the team lead for the JUnit team. And he is the guy who is responsible for catching most of the bugs in your software, I hope. So, Marc, welcome.
Thank you. Yeah, welcome from my side as well. I can just start, basically. I'm Marc. I'm a software engineer. I'm currently self-employed and actually working full-time on JUnit for the first time ever. I've been a JUnit committer since 2012, and I was elected team lead in 2016, so I've been involved with the project for a long time. And yeah, I'm happy to be here today. JUnit in a nutshell, if you haven't used JUnit before, I highly doubt that's the case, but in case you have never heard of it, it's a project that's quite old in terms of the Java timeline. I think it's one of the oldest Java open source projects probably that's still around. It was originally created by Kent Beck and Erich Gamma in 1997. And it's an independent open source project. That means it's not backed by a company or part of any foundation. So most of the work usually happens in the spare time of contributors. And yeah, we will see today that right now it's not the case, but usually that's the case. And at the same time, it's one of the most popular Java libraries. So there's a little bit of conflict here. I would also like to use this opportunity to thank our sponsors, because we have sponsors that basically give us money every month. We use that money to have team meetings every now and then, where the whole team comes together. And we have a co-located couple of days where we can discuss new issues and actually work on new features. And yeah, really happy that that's the case. All right. We had another piece of good news actually last year, namely that the Sovereign Tech Fund is investing in JUnit in 2024 and 2025. And that allows me right now to work on JUnit full time. So you might not know what that is, the Sovereign Tech Fund. So it's a German government program that aims to strengthen the open source ecosystem. So it invests in foundational technologies that enable the creation of other software. And yeah, we're really, really happy that JUnit is considered one of those, and that I have this opportunity right now to get things done that I've wanted to get done for a long time.
Okay.
And work on JUnit more.
That's great.
So there are a couple of generations of JUnit. You've probably seen 4.x. I know that it's still being used, right? And it will never go away probably fully. So that's still around, and people have legacy code bases, or they have some code, and legacy is not necessarily bad. It just was written before JUnit 5 was around, and the 4.x generation uses a Java 5 baseline. So that's really old, right? And right now it's in maintenance mode. That means we will not add new features to the 4.x generation of JUnit. But of course, if there's any critical issue or a kind of security bug, we would fix that. Most of my talk today is going to be about the 5.x generation of JUnit, which was released in 2017, also quite a while in the past by now. It has a Java 8 baseline, and it supports modern features of Java, but it also supports Java 8. And a little spoiler alert, so today we're going to also talk about JUnit 6, but you'll have to wait a bit until we get further to the end of this talk. All right, so what I'm actually working on right now, since I'm able to work full-time on JUnit, the first thing I did was improve the release automation. And that's something I always wanted to do, but it was never important enough to invest time in. But now I'm really happy that we have it. The last couple of releases were much simpler due to that. Today, we're going to talk about better test reports. So that was already shipped in 5.12. We're also going to see parameterized test classes in action. That's a 5.13 feature, which was released just last Friday, actually, just in time for today. And reporting of test discovery issues, another important piece that we always wanted to do that was in the issue tracker for a very long time. And finally, I had a chance to work on that. I'm currently wrapping up improved Kotlin support. We won't talk about that today because it's not quite ready yet. And next up, we'll also implement some more advanced features like safe cancellation of test execution which means, for example, if you run your tests and already hundreds of them failed, you probably don't want to run all the tests.
Oh yeah.
Right? You won't be able to look at that anyway. So, but still, currently the only way to stop it is like kill the JVM.
Yeah,
and,
totally.
And that means like all the shutdown behavior, maybe the cleanup behavior in your test classes won't get executed, and you might like leave resources lying around and stuff like this. So we want to improve that.
For JetBrains platform, we have like 300,000 tests, and probably it is not worth running all of them if you first a couple of 100,000 fail. So yeah, very useful feature.
Yeah, cool. Yeah, we also want to make some improvements to parallel test execution. That's already going to be in 6.1 probably, right? So this timeline in the future is always take it with a grain of salt.
Yeah.
And last but not least, the documentation is relatively good, I would say. So we have a large user guide, but I think it could be more approachable. It's this large, huge document right now. And while it is kind of versioned, there's no easy way of navigating to a specific version or even signaling to the user that they are looking at an old version of the documentation. So that's something that we also want to address as part of this work. Today, as I said, we're going to talk about these three items: better test reports, parameterized test classes, and reporting of test discovery issues. And last but not least, we're also going to see what's up coming in JUnit 6.0.
Oh yeah, waiting for that.
All right, let's get started with better test reports. And this is based on the Open Test Reporting XML format, which was actually introduced in 5.9 already, so a couple years in the past. It's intended as a replacement for the legacy XML format, which lacks support for like many JUnit Platform features, like tags, for example, hierarchical structures, nested tests, parameterized tests. All are not really represented well in the old format. So we introduced this new format, and we'll see it in a second. It requires an additional runtime dependency, actually. So you need to add JUnit Platform reporting to your test runtime class path, and then you need to enable it via a relatively simple configuration parameter that you can pass as a system property, for example. And then you will have this new format written alongside maybe the old format that your build tool might write, and we'll see that in a minute. So this is what it looks like, actually. It's event-based, so you will have like a started event and a finished event for each kind of node in the test tree. So in this example, we have JUnit Jupyter, which is the test engine. We have a top-level test class, we have a nested test class, and we have a test method here, right? So these are all started, and then in the reverse order, they are finished, right? So this is a small example. You can still see what's going on, but this is not meant to be human readable,
no,
right?
No, totally not. Yeah. So,
it's very suitable.
It is still XML, yeah.
Yeah, it's XML, and it's also you need to like match these event IDs together in your head to see like everything that's going on, to like see the result of this.
XSLT for that or something like that.
Yeah, kind of. But it's very suitable for writing. So if you imagine you have to implement some listener that writes this format, you don't have to like
just getting events
wait until everything is finished. You can just write the started event and finished events as they happen. And yeah, this gets even worse if you enable parallel test execution.
Yes.
Then things will be like all over the place. I mean, it will still make sense if you like look at this, but it's really hard to read.
Yeah.
So we thought, a different format might be better. So we have the second view on this, basically. It's a hierarchical format. It uses the same kind of elements inside, like this metadata here, for example, or the sources. That's also present in the event-based format. But here we have, the test tree is there. So for example, here we have a root, that is the test engine. Yeah. And we have a child, that's the test class, and that has another child, which is the nested test class, which has another child, which is the method.
Yeah.
And you can see like, okay, the result of this method was successful, and of this test class also, right? You can see the sources, and so this was this Java class where the test is actually defined, or here we have a method source for the method, where this is coming from, this method in that class. So I think it's a bit more readable than the other thing. You don't need to match these IDs together.
Not exactly, but yes.
Yeah, fair enough, right? So it's still XML, as you said, and it's not very human readable. So the idea was, and we always wanted to do this, and eventually get to the point where we have an HTML report, which makes this much more approachable, and we will see that in action now. So let's see. All right, so I'm using just a regular random open source project here, fast CSV. Nothing special about it really. I want to demonstrate that it's relatively simple to add this to an existing project, right? So I'm not using a playground project or anything. I'm using a real world project, which is not huge, but it has a fair number of tests. So we will see what we have to change. One thing is I updated the JUnit version to 5.13 here, right? So that's just the latest version. And I also had to change the build script a little bit. One thing is adding this JUnit Platform reporting runtime dependency. So that takes care of actually writing the event-based XML format. And then we also have to enable it. That's this configuration parameter I mentioned earlier. And one other thing I'm doing here is I'm customizing the output directory. That means, okay, the XML report is going to be written to that directory, and it's kind of specific to the task, because we actually have two test tasks in this project. There's a regular Gradle test task, and there's a special in-test task. All right.
Okay, it's more readable than XML?
We'll see. So let's see. Okay. So that's basically the changes we had to do to the Gradle build of fast CSV in order to enable this new format. And let's run the tests now. So these are all the tests of both test tasks run in IntelliJ. And you can see like this is the usual kind of test tree that you get. For example, you have this class, which has a parameterized test here. And you can see like all the invocations of that test in the test tree. All right, so let's look at that event-based format just once again. And you will see that this is what has been written by the listener, right? You have the started event and yeah. And in the event, you have the finished event.
Very machine readable.
Very machine readable. We can agree on that. All right. So how do we convert this to something we can read? And the Open Test Reporting project actually provides a CLI tool, and I'm using that here. I'm using JBang here. If you're not familiar with that, it's a tool that lets you run Java programs relatively easily.
Yeah.
It's not strictly necessary here, right? So these coordinates here basically point to a jar that's executable on Maven Central, and this is just a nice, easy way of delegating the downloading of the jar and managing that to JBang. So it will basically download this executable jar using these coordinates and run it for me. Yeah.
Cool.
And all the rest here are actually parameters for that executable Java program. So I'm using the HTML report subcommand here. I'm telling it where to write the output file to, the HTML file. And I'm giving it like both input files, because we had two test tasks here, test and in-test. We have two files. And last but not least, I'm telling it to open the resulting HTML report in the browser. Right? So let's run this. And this is what it looks like. So what we see here on the top level, when we have the status, maybe you should start there, right? So it's a green bar. That means everything's green. If there were a test failing, it would be red, right? We have these two XML reports that we have included in the HTML report, one for the test task and one for the in-test task. And we can see the infrastructure this ran on. So in this case, this ran on my local Linux laptop. You can see some information about the Java virtual machine this ran on, what's the max heap size. And last but not least, you can see the Git repository. So this is just basically the origin URL, which branch this was on, which commit hash, and also a little summary of the working tree, if this was clean. So on CI, usually this would be empty, right? Usually you run commits on CI that don't have any local changes. But since I ran this locally, I can see, okay, I made some modifications to these files, just so if I send this report to someone, they will know, okay, what did you actually change in that file, right? Yeah. Maybe that was the reason why the test started failing. Yeah. That's the idea here.
May I ask a quick question?
Sure.
So do you have any integration libraries to integrate those reports with any CI system? Like how easy it would be to publish the report in my CI if I would...
we'll actually get to that.
Okay,
just a little
fantastic.
Longer.
Yeah, sure.
No worries. Yeah. Yeah, I will actually show that because we have them. And just to make the point that this is actually the same test tree that you would kind of see in the IDE, right? We have this extra level of the engine that the IDE hides from you. But apart from that, we've seen this previously here, right? So we have the same tree, and you kind of don't have to make this mental mapping of, okay, this is what the HTML report shows me, this is what the IDE shows me, but it should be relatively the same. So that's what this
convenient.
What does. Apart from that, there's some basic filtering here, like you can filter out all successful tests, which leaves nothing.
Which is similar to what we have in IDE.
Yeah, kind of. So that's the idea, right? And the most important feature of all, there's dark mode, right? Just kidding. Of course, that's not the most important feature, but people will ask for that if you don't have it. And now we get to the CI part, actually. So we have the CI build here on GitHub Actions. This is the CI build for the Open Test Reporting library itself. We can go to the latest build here. And what this build does is actually archiving the HTML report here. So we have Linux, Windows, and macOS here. And each of these will run the tests. So we have 3 artifacts that are archived. I will just pick one at random. Let's do the macOS one. Unfortunately, GitHub Actions doesn't let you browse the files. So you need to download the zip file and then extract it and open it. So it's less convenient than it could be. But it's kind of usable if you want to know what's going on CI. So you can open these reports locally. You can download them. And the HTML file itself is kind of self-contained. Right? So there's just one file. You could even send that to someone and open that. And here, this is a sample test class called kitchen sink test, because we threw everything in this test class, including the kitchen sink.
Yeah.
So we have a fail test here that shows you, of course, you get the exception stack trace if something goes wrong. And there's a convenient way of copying that, and you can go to the IDE and look at the stack trace, if you can type. So there you go, right? And you can navigate to that place where the assertion failed.
That's convenient.
That's a nice feature and idea that you can analyze stack traces. And here we have this class, right, where we have this fail test. And one thing I also wanted to show is this test reporter thing. It's a Jupyter feature, but it's also like platform support for it. That lets you publish kind of report entries. So in this case, it's a string map. Yeah, just some sample data, and you can also see that in the report. So this gets kind of also included in the report.
Oh wow!
You can attach files as well. So here we have a test.txt file with just a single line and some special encoding, and you can see that here. So if it's a text file, it's actually be shown inline. It's not limited to text files, and standard output and error is also captured.
Can we collapse or expand it? So if it's like million lines long?
Yeah, it will. The text box will have a limited height. So yeah, it will not explode, but yeah.
Okay, we have a couple of questions from the chat.
Go ahead.
So, and the first question from Vladimir, he's asking, I wonder how the report compares with Aloo report, which is probably a richer test report.
Yeah, I think Aloo had more features than this does. This is meant as something that everyone can basically use, and it's easy. That supports all the JUnit features. So I think if you're already using Aloo, you probably don't want to switch to this. But if you're not using any of this and maybe using, I don't know, whatever reports your build tool provides, this is a good start and relatively easy to add. Okay, great. And yeah, there was a suggestion saying let's use a random open source project like test containers and migrate it from JUnit 4 to JUnit 5. But yeah, it was kind of a joke because it will take I think someone's already working on that. Actually. Yeah. But yeah, let's not do it during the demo. Maybe that will take. Yeah, there is a question regarding the PR in the JUnit 5 and any particular PR, but I think we can discuss it after the session if we'll have time. And yeah, I believe. Yeah, we can talk. Vladimir, we can talk to you regarding this PR, particularly. And yeah, I think. One more thing. They say status of the working tree is inherently insecure, as it might publish private file names. Do you think it is an issue? That's a good point. I don't know, off the top of my head, I don't think it's really an issue because, I mean, you don't have to send this report to anyone. Like, and like if you archive it on CI, then
nobody
everyone that has access to your CI build should also be able to see the file names on the CI server, maybe? Yeah.
Cool. Yeah.
Sure. I mean, maybe we should add a way to disable it if it really is a security issue. I mean, with any of this, I mean, we have a GitHub repository with an issue tracker, right?
Yeah.
So if you're kind of people can. I'm really encouraging people to report issues and feedback, and that's the way to. That's the basically way to
improve
do it.
that.
Yeah.
Okay. May I ask the last question, and I believe we can continue. So they say since GitHub Actions is here, have you guys ever considered creating GitHub Action which will embed JUnit report into GitHub Actions UI?
Yeah. So. Unfortunately, it's not really possible. I mean, the thing is, the actions can write the summary, but it's limited to Markdown.
Yeah.
So you can't really embed any like HTML. I mean, it has some HTML support, right? But you can't do fancy things like this. Embedding this whole report there is not possible, to my knowledge. But yeah, I mean, I'm getting to that. So right now we have this HTML report. It's pretty new. Please do try it out and provide feedback. Yeah, and that's eventually something we can do at some point, right? Or someone else can do. But yeah, sounds good. I mean, sounds like people are interested in that HTML.
Totally. Everybody's interested in that.
Awesome. There's actually one little more thing I wanted to show. Let me just get to that, and then we can move on. Yeah, we also have like support for screenshots and stuff. Like if you have file attachment, like here, this is the HTML report writer. So I know it's a bit meta.
Yeah.
But we have a screenshot of the report, how it looks here, right? So images are actually also embedded here, and you can look at them, which could be useful for like browser tests, like this one, which uses Playwright in the background, and things like this. Yeah. Okay. Any more questions? No?
Not so far, I think. Yeah, there are some comments regarding the number of tests and the size of the HTML file. And yeah, the addition to the report publishing, they say at least test run summary would be nice. I mean, for GitHub Actions.
Yeah, definitely. Yeah, I mean, there are actions that do this based on the old XML format right now. Yeah. So maybe we should talk to those people that maintain those already, if they want to adopt this new format as well.
Anyway, we will have some time to go through the chat again and contact interested persons.
Yeah, awesome. Thank you for all the feedback. That's great. Yeah, this whole format is platform agnostic. So like in the core schema is an XML schema. There's nothing Java specific or JUnit specific in there. Like as long as your testing framework in whatever language has like a test tree kind of structure and something can fail, then you probably can use this format. And adoption in other ecosystems actually has already started. So as part of this work, I reached out to a couple of folks, and the PHP unit maintainer has already shipped support actually in PHP unit to optionally enable this format as an output. So that's pretty cool. And I'm looking forward to seeing how this is going to develop in the future as well. And this is the slide I wanted to talk about all that, right? Yeah. So yes, I mean, right now there's no Gradle plugin or Maven plugin to like enable this on the fly without you having to touch your build. That might be something we could add, or a GitHub Action integration. That's something that maybe at least archives those things or prints a test summary in the Markdown. That would be useful. And again, any feedback you have or any request, then please let us know and open an issue on the GitHub repository. All right, that's the first topic covered. And we're going to move on to parameterized test classes. If you have used JUnit since 5.0, there's a parameterized test feature. So just a short recap here. Instead of the test annotation, you would put this parameterized test annotation on a method. And then you have to add a source annotation. Like that means like where are the arguments actually coming from? What's the source of arguments? And the simplest possibility is usually the value source annotation, which specifies them just here like inline as literals. So in this case, this means this test method will be executed twice, once with foo as the value and once with bar, right? So that's kind of the idea here. And of course, you can have multiple parameterized tests in one test class. And sometimes, like in this made-up example, you parameterize them the same way, right? So, which is kind of a duplication that you might want to remove. So one of the most requested features was adding support for parameterizing test classes instead of methods. And we finally got around to doing this now in 5.13.
Finally,
so,
yeah.
Yes. Well, for me, finally. I always wanted to do it. I kind of started so many times. And yeah, so instead of the parameterized test annotation on a method, you now put the parameterized class annotation on a class, right? You can use the same source annotations on the class level now and specify the arguments. And in this case, we're using field injection to inject this one parameter to this one field. Of course, you can have multiple parameters. And it's not limited to a single one. And then you would have multiple fields annotated with an index. Or you could use constructor injection, because we support both, right? So you have to pick, do you want constructor injection or field injection? And in this case, it's a record class. You can also use record classes with constructor injection. You don't have to use record classes. You can also use a regular test class. This is just a nice, convenient way of, not writing the constructor yourself and instead declaring the parameters as like record components here. And then the tests can use the field that is generated for the record. In the same way they could use the field here where you have explicitly declared it, right? So all the tests basically use that, and that's what it looks like. So let's jump into some demo then. All right, let's close everything and go to list tests. So one common use case for parameterizing on the class level is if you want to run the same set of tests against different implementations of an interface. So instead of coming up with my own interface here, in this example, I'm using the list interface. So I want to write some tests against the list interface. One test is relatively simple. A new list is empty, right? The second test is I can add an item to the list, and that method returns true. The list contains the item, and the first item of the list is the item I just added. Very basic tests, right? I mean, this is just an example. Imagine your own implementations, your own interfaces. And now, how does this actually work? Well, this is an abstract class. This is like the base class for your tests in this case. And you would have an abstract method somewhere that would actually create the list for you, right? And then in this case, we're using a field here to store the list and have a before each lifecycle method that is called before each test method to create the list and assign it to that field so that the tests can use it. Yeah. And then here comes the verbose part. To actually run the tests against different implementations of the list interface, you would have to define subclasses of the abstract test class, like array list test, linked list tests, and vector tests here, and override the create list method to return the concrete kind of instance of the implementation class.
Yeah. Classic, yeah.
So
we all did that.
Basically what you had to do before parameterized test classes were around. You can of course run this, right? And what you would get here, we're using the nested feature of JUnit. So we have these all nested under list tests. We have one for vector, one for linked list, right, and one for array list. And each of them has like these two test methods that get executed. All right. So how does this look with parameterized tests? So here is there's a new test class that has the same test methods, right? And also has a field list. And I'm using the new feature here, parameterized class, and I'm using a method source. So this method source is this method. IntelliJ helps me here and knows that it's that method actually. And it can return a stream of the arguments. In this case, I only have one argument, namely the concrete list implementation instance. And I'm going to inject that using field injection into that parameter annotated field. And yeah.
How can you match the method source parameters with the fields? Because they can be more than one parameters, I believe.
Yes. So if you have more than So the parameter annotation actually has a value,
Yeah.
and that's the index. So if you have like more than one, you need to
Specify the index of this parameter.
Yes.
Okay, not the name, but just an index.
Yeah, it's just an index, right? So that's like the list of the constructor arguments.
Yeah.
In this case, you would define them as fields.
Okay, got it.
Good question. Yep, we can run this.
While it's running, is the order of tests guaranteed?
No, I mean, well, here, yes, unless you enable parallel test execution.
Yeah, okay.
Yeah, I mean, here we have this order guaranteed. As you can see here, for the nested tests, it's actually not guaranteed.
Okay.
Because we use the reflection APIs to look for these tests.
Yeah, it depends on how compilation
doesn't guarantee any order.
Yeah.
You can use a class orderer, custom one.
Yeah.
So you can actually specify, I want my classes ordered in this way, as a class level annotation. Yeah, here, test class order. And then you can say, like, order annotation, for example. That's the wrong one, this one. And then here you could put like these order annotations on the nested test classes, and then they would always be run in that order.
Okay.
Yeah,
fair enough. So you need to specify order just explicitly to be ensure that everything goes.
I mean, ideally you don't have to rely on the order, right? So it should
totally. Tests should be independent. Yes. Okay. Thanks.
It's actually funny that you mentioned this because we do have a kind of problem here in this test class that I showed. This parameterized list test class. It actually has an ordering problem, right?
Yeah.
Because we create this array list here.
Yeah.
And each of these tests will use that instance of that list, right? So if this list, if the second test here, items can be added, would run before the first test, it would actually have a value, right? So we were actually just lucky here. So so I wanted to bring that point across. So if the data is mutable that you use, then you have to be careful. So let's see. For the methods, you can also use an orderer. So this is not test class order, but test method order. And let's say I want to run this one first before this one. And let's run that. I will fail, right? Because now items can be added, ran before, and added this item to the list.
Yeah.
So that's the problem with using mutable values or mutable instances as parameters.
Yeah.
You can get around this by adding a before each method, or after each. Let's do an after each. And say like clear list, and then you would do like list clear, and then after each test method is executed, it would be cleared again, and then it would be okay, right? But ideally, you wouldn't even have to use that, and would pass in immutable data. And we have another example here where I can show how that works. And that's this one. Yeah, so here I made the switch from field injection to constructor injection. Mm-hmm. And here we have, we actually pass a supplier and not an instance of the list. So the supplier itself is immutable. Yeah. It will create a new list every time it gets called. And since we use a constructor here, and every test execution for every test method gets a new instance of the test class, the supplier will be called in the constructor, and every test will have a new list to work with. Right? Yeah. So that's something to be mindful of when you write tests that use mutable data. All right, and we have more examples. So let's see, because you can also achieve the same thing with value source. So we're using method source here, which calls this method, right? And I have an example here that uses value source, where you can just specify the class literals here.
Class literals. So classes can be okay.
Yeah, you can.
You
basically value source supports whatever was possible with Java annotations. So you can have class literals in Java annotations.
You can.
You can't have instances or anything. I know Kotlin's different there, but for Java, this is what Java supports. So classes are one thing. And here we use that to specify the concrete implementation classes.
Yeah, okay.
And then pass them to the constructor, which in this case, since it has only a class instance, has to use reflection to instantiate it, right?
Yeah, if it doesn't have like default constructor,
yeah,
it
sure.
might be tricky.
Of course, this relies on having a default constructor,
Yeah.
right? Which collection classes tend to have. So
Usually.
kind of fine, but yeah, it's not super clean, right? And so this is just an alternative. But usually, maybe it's fine to write your method and use the supplier approach, or even have your own record class that kind of encapsulates what you need to do.
I think our guys
might be worth it.
So our attendees know all think about how to implement it in their cases right now when they figure it out.
Yeah.
So using reflection might be tricky, hacky, but still it is a way.
Yeah, I mean, since you run your tests, right, it might be kind of acceptable if you do this in test code. But yeah, it's ideally you wouldn't have to resort to that. It's true. I mean, in JUnit itself, of course, a lot of reflection is used to instantiate the test class, and run the test methods, and all of that.
And some bugs can be reproduced only with like hacky things. So yeah, using that is, I think, is permitted.
Yeah. There's one more feature I wanted to show here. You can, instead of writing a constructor, you can also use a converter.
Okay.
So here you would annotate your field or your constructor parameter with convert with, and then you would kind of do the code that you had done in the constructor here. So that could be reused, and you wouldn't have to define all these constructors if you use this multiple times. This might be an approach, right? But this is not the only thing, of course. You can just convert. You can convert strings to your data types, for example, or something like this. For example, if you want to define dates in a value source as strings, you can like have a converter that converts them to local date time or instant or something like this, which would be also kind of useful. So in this case, we're using it to instantiate a class, and that will be then injected by JUnit, right? So there's a bit of magic here.
No magic, I think. You just provide a converter.
Yeah,
basically this is
visible,
converter.
right?
It is visible.
Yes, true.
There is no reflection. There is reflection technically, but it's visible.
Yeah.
So you know what's happening.
You can also use this on constructor parameters. It doesn't have to be a field. So if you use constructor injection, you can define it here, and this will work in the same way. All right. Yes. So there's also support for a custom lifecycle method for parameterized classes. So sometimes you need to maybe initialize the object that you want to work with in your tests. In this case, for example, I'm using, if it's an array list, I'm calling an array list specific method here to ensure the capacity. I don't have to do this. This is just an example. But for example, if you have some object that has an init method that needs to be called before it actually can be used, this would be a way of doing so. So these before parameterized class invocation methods need to be static, and then because we create the instance only later, right? So each test will get a new instance, and this argument set, this list, is kind of used for both invocations, both instances, so they need to be static. But you can like declare the parameters here again if you need to access them, and in this case use that to initialize the instance that is used in those tests. Again, I don't think this is something you need to use every day, but it's there for such cases where you kind of need to make things work and initialize something before it's used. All right. Well, last but not least, I have a more complicated example because this was too easy. You can, of course, combine parameterized class with nested. So here we have the same class we've seen previously, right? But we also have a nested test class inside that test class. And it uses the same parameters. So, for example, if you want to test array list against linked list and see that their two are interoperable, that would be one way of doing this. So to create the Cartesian product of both dimensions of the first three array list and the second three list implementation classes, you could do it like that. And of course, within each test class, you can also use parameterized test classes. parameterized test methods, sorry. So you can combine parameterized classes with parameterized test methods if you really need to.
So you have like a combination
Yes,
explosion.
you can quickly explode everything. So use this with care. So this is what it looks like if you run it. So we have the first 3 items here that are on the test tree. The first, these parameters of this test class, right? And then within each, we have the 2 test methods that we've seen multiple times before. And we have this nested interoperability test class, which also has 3 invocations. And it happens to use the same parameters. Of course, this could be a different thing. You might want to combine, I don't know, strings with ints or something, right? You could do that in this way as well. It doesn't have to be the same set of parameters. And within each of those, we have these 2 test methods, and one of which happens to be a parameterized test method, which also has 2 invocations. So yes, you can combine things and test Cartesian products this way, but if you overdo it, then you quickly will have a big
totally
explosion, right? That's just the power of this, for sure.
Yeah, while we have some time, do you have those examples on GitHub somewhere?
Yes, I do.
Okay.
I can show that. Let me see. I actually just pushed them this morning. So let's see. I have a link in the slides somewhere, but it's here if you can't wait. So it's Marc Philipp, my username, JUnit Demo 2025 on GitHub.
Okay, fantastic.
Cool. Okay. To recap, I think I made the point that things should be immutable. Ideally, if they are mutable, you need to take extra care to make sure your tests basically don't depend on each other, and you can run them in any order. Lifecycle methods, like after each, are kind of a way out of that. So to reset the data. But ideally, they should be immutable. We have a bunch of source annotations. We've seen only value source here and method source, right? But you could also have different ways of
that could be extremely useful.
Things. Yeah. So one I like, for example, is enum source. If you have like something that is just like not maybe in enum, but you can misuse an enum to implement something, and just specify enum source, and it's very convenient. If you add an enum constant, it will automatically adapt and adjust all the tests.
And there is a provider, so you can...
Yeah, this is extensible. Like what we try to do in JUnit, everything that we do, every feature that we ship uses extension points, kind of. So all of these are implemented like this, basically. And they have a provider that is kind of reading the annotation and providing the arguments based on that.
Yeah.
And you can define your own provider if you need that.
Yeah, there's a note asking probably me, can IDEA inspect mutable object used across different test methods? I think I should ask Tagir about that, whether or not we have like code flow analysis saying that there are mutations of the object in the tests, including like not including order of the tests. Basically, I don't know, so I will figure out, and I think it would be useful for IntelliJ IDEA to have such an inspection. Yeah. So it's kind of not writing tests for tests, because, well, in IntelliJ IDEA code base we have some flaky tests which are failing sometimes, so you know how it happens.
Sure.
So maybe this could be a good addition for that. Yeah, thanks. So,
yeah, I mean, it's a pretty new thing, this whole, it was just shipped last week, right? So we can discuss what IDEA should best do there. Yeah. And we also talked about these lifecycle methods that are special for parameterized classes that you probably don't need to use every day, but they're there if you do need them at some point. All right. If there are no more questions about...
there's one question. Does it make sense adding test method order and argument method order.random for parameterized test classes to capture such ordering issues?
Yeah, it might. I mean, you can also configure that globally even, that things should be, if you want to make sure that stuff never is order dependent. That might be one way.
Yeah, it might. What I don't like about randomness that test data should be like reproducible. Like tests should be reproduced on random order.
Yeah, it's a bit like
it's not about random. It's about
like mutation testing in a way.
Yeah.
Like maybe that's an additional step. You can actually configure a default orderer via configuration parameters.
Yes.
So you could have like a separate stage on your CI that injects that basically and runs all your tests in random order to see that, okay, they behave the same way.
Yeah.
If you can afford that, of course, to run your tests again, right? So if they take hours, then that's probably not an option you do have.
Yeah.
Or maybe you can do it on a subset of your tests, stuff like that. But yeah, it is possible to do both test class order and test method order from the outside. You don't necessarily have to use the annotation to configure it.
Okay, so let us continue.
All right. Last topic, discovery issues. So what's a discovery issue? Have you ever written a test where you noticed at some point that it wasn't actually executed? I have. And that's the stuff of nightmares for me, right? So that's like the worst possible thing. I've written this test and it isn't actually being executed anymore for some reason. And my bug made it to production basically because of that. And that's not something that should happen. So ideally, JUnit should protect you from that. However, we have 2 examples here, right? So are these valid test methods? They have a test annotation on them, right?
They look like them.
They're called test, which is not really important, but
for JUnit 3, probably.
Yeah, for JUnit 3 it is, but okay, we're talking about JUnit 5 here, JUnit Jupyter. So these are not actually valid test methods because test methods must declare having a void return type or unit in Kotlin, and this one returns an int in Java or nothing in Kotlin, which is not unit. Oh, there's a T missing. Sorry about that. Kotlin. I'll fix that later. Anyway, so these are not valid test methods. So what happens with them? What do you think?
I think they either won't run or fail the test engine. So there are 2 options.
Yes. So what happened before 5.13? They were silently ignored. So during the test discovery phase, JUnit will kind of scan the test classes that it's passed as kind of selectors and look for test methods. And it will check, are they void, are they non-private, are they not static, things like this. And if they are, up until 5.13, they were silently discarded. So these 2 test methods that we've just seen, oh, sorry, that was wrong. Here, they were just discarded and not being taken into account.
Just wonder if we have inspection IntelliJ IDEA for that. I believe we do.
Yes, there is that. So to be fair, that's my last point here. IDEs such as IntelliJ do offer some inspection for that, right? I mean, but not all people pay attention to things being, yellow or something in the IDE.
Unless it's red.
Yes. So there is some assistance in that for sure. So this is where this new feature comes in, test discovery issue reporting. So that means test engines can now report issues that they encountered during the discovery phase, such as malformed declarations like this, right? Where there's a return type that shouldn't be there or some other issue. And the JUnit platform will kind of collect those and it will log all non-critical issues. There's warnings, they will be just logged. And critical issues will actually cause the test execution of that engine that reported it to fail when you execute the tests.
Okay.
So you see things, right, are happening. And the critical severity is configurable. By default, it's just error. But you can also say, okay, all warnings should also fail, or all info level messages should also kind of fail test execution. So kind of similar to what you can do with compilers. You can tell them that warnings should be treated as errors. So you kind of are made aware the build will fail if you introduce something that produces a warning.
Yeah.
You can fix it immediately rather than reaching a state where you have hundreds of warnings and don't even know where to start, how to resolve them. And this is the idea here. All right, let's see one in action. So I've done my best to write some wrong tests here. So this is a malformed Java tests, right? We have the test from just now that returns an integer. We also have a test factory method here that returns object. It's a bit fishy maybe. We have a nested test class that has a test method. So when we run this, what will actually happen. So only the test in the test factory will be run, so this dynamic test, and the inner tests won't be run, and this test method here also won't be executed. What we see here is we have these new warnings that are printed to the console by JUnit. We have the test method that returns an int, right? It must not return a value and it will not be executed as a result. We have the nested class, must not be static. So that was actually a mistake. So this should not be static. Nested classes must not be static. And we have an info level message that says, yeah, the test factory method, as we can see, this was executed, right? The return type that's declared is Java lang object, so there's no way JUnit can, like, during discovery, figure out if this is a valid return type. It might return something that is compatible with a test factory, like a list of dynamic tests in this case, right? But it might also return a string or something, which is obviously not a dynamic test. So we should really, do this better and declare a proper return type. That's what this info level message is trying to tell us. And as I said, what I would recommend people, especially if they start a new project, maybe, at least set this to warning, this critical severity level, right? So if you set it to info, this will actually fail. Same would happen if you set it to warning. So then this happens, the reporting maybe is not ideal, but at least it fails. It's red and hard to ignore if this fails during your CI build.
Something is fishy, yeah.
And then we can see that these are not treated as critical issues. They're no longer non-critical. And these are the same issues, right? So we can go and we can fix them, which is just, return nothing. And here we would return a list of dynamic test. And here we will remove the static. And then if you run this again, all the issues are resolved and all the tests are executed as they should be.
Great. May I ask a question?
Of course.
So what triggers the engine to analyze this workflow? So, well, if I have a utility method in my test, in my unit test, will it fail the execution if I have the...
No, it will just look at test annotated methods.
Okay.
So if you put a test annotation on a private utility method, that doesn't make any sense. Right? Why would you do that?
Yes.
And of course, then the right resolution is to remove the test annotation from something that's not actually a test method. But in my experience, usually it's the other way around, and you have something that prevents a intended test method from being treated as a test method by JUnit.
Yeah.
And then.
Yeah. Okay. So got it. Yeah. Thanks.
Yeah, to be fair, I kind of cheekily collapsed this warning thing here. So that's the warning you mentioned. Like, now it's redundant, right? So, but IntelliJ actually does try to warn us. So if we remove that, we'll get this, right? So it's like, it should be void,
it should be
right?
Void.
And even here,
so
it should not be static. It doesn't say that actually, but.
Quick question: what is default value for failing the test?
It's error.
Error. Okay.
Yeah. So mostly for backward compatibility, these things are warnings, so they won't fail the build. So you can upgrade to 5.13 without everything blowing up if you have this case.
Yeah.
But I would recommend, setting it to warning and seeing what happens if you have any issues actually in your code base once you have the 5.13 update taken care of.
Okay, great, thanks.
Right.
So we still have some time. So roadmap.
Yeah, roadmap. Last but not least, I'm going to talk what 6.0 going to entail. And first off, the good news, there's not going to be a huge kind of breaking release like 5.0 was in terms of you don't have to migrate your tests to a new API. That JUnit Jupyter API will stay as it is. The things I've shown today are available in 5.13. They will also be available in 6.0. And also the IDE and build tool integrations will continue to work. We'll make sure that's the case. We will maybe introduce some nuances here and there, like what I talked about in the beginning, this graceful way of shutting down test execution early. That is going to be some addition to the API, but it's not going to break existing APIs. That's the idea. So overall, like migrating from 5.x to 6.0 should be much simpler than from 4.x to 5.0. That being said, there will be some major changes in 6.0. So we will require Java 17, right? So if you're kind of stuck on Java 8, you can't go to 6.0. We'll also require Kotlin 2.2, which will be the latest release at that point. One new feature is that we have nullability information available across all the APIs using JSpecify in 6.0.
We'll talk about it later with Sebastian.
Yes, exactly. So that's something that's really cool and coincided with us starting on 6.0. So that's a new thing. We'll remove some APIs that have been deprecated since 5.10. That's like, I think, 3 years in the past. So those will be deleted. And we think there's been a lot of time with the deprecation in place that you have had a chance to migrate off of that. Which also includes this JUnit Platform runner. Not sure you're aware of that. That's was a mechanism we introduced at the very beginning when IDEs did not yet support JUnit 5. So you could run a JUnit Jupyter test using JUnit 4.
Yeah.
So it's kind of an adapter kind of thing. And yeah, we don't think that is necessary anymore. So that's discontinued, which also has been deprecated since 5.10 or even earlier. I'm not sure. And we also deprecate some kind of JUnit 3.4 compatibility layers. So the JUnit Vintage engine is one of those. That's the thing you need to have in your test runtime class path in order to run JUnit 3 and JUnit 4 tests on the JUnit platform. That will be deprecated. We will not deprecate it for removal just yet, right? So it will be around for a while longer. But it should only be used like temporarily while you migrate from 4 to Jupyter or some other platform compatible testing framework. So that's the idea behind that. And the second thing is migration support. Not many people use that. It's a collection of adapters basically to be able to use JUnit 4 rules, which was the extension model, kind of a newer extension model in JUnit 4, as JUnit Jupyter extensions.
Okay.
So you could external resource could be used as like a Jupyter thing. And there's clear migration paths how to go from a rule that was supported by that migration support layer to a Jupyter extension. So
and there was a question regarding that.
Put in the time to actually do that if you're still using that. But that's not an issue for many people. We have at least the download numbers from Maven Central that show us that it's not used as frequently. But yeah, don't panic. So if you're kind of stuck on, I don't know, Java 8 or 11 or something, we will have let's call it longer term support for 5.13.
Okay.
So usually we only support it always the latest feature release. So that's 5.13 right now. It was 5.12 until the end of last week. And we didn't really backport any bug fixes to earlier releases. Sorry, if you encountered a bug right now, it would only be backported to 5.13. And last week that was 5.12, but not 5.11. And now we kind of promised that if we find a critical bug, even after 6.0 was shipped, we will backport that to 5.13. And it will stay on Java 8, so we won't change that. Obviously, so you can continue to use that if you kind of can't move to Java 17 or later yet, and we think that's good enough, right? We won't backport new features to the 5.13 line, but we will keep supporting it in terms of bug fixes and security stuff. So that's there.
Great, thanks.
Yeah, trying.
No, we don't have any major questions.
Okay.
People are just say thanks. So one note from the chat saying please consider the GraalVM thing. I don't know what does it mean.
Well, we actually did spend some time on GraalVM and talking to the GraalVM team.
Okay.
And they actually have completely rewritten their support. The native build tools plugin is not out yet.
Yeah.
But yeah, we have been working closely with them. I don't know which specific GraalVM issue they're talking about, but yeah.
Nothing clear. Okay. Thanks for this story. So it looks like sparks a lot of interest in our chat, and I believe we answered all the questions. I think that concludes our session. Thank you very much for your talk.